Today we are going to spend day 1 on chapter 5, section 4, and we're going to be solving right triangles. So we're going to label our triangle. You're going to label the angles with capital letters. You're going to label the sides with lowercase letters, and then you're going to be using SOHCAHTOA. You're going to be, when we solve for a right triangle, when you're done, you're going to have the measure of all 3 angles and all 3 sides. Now, as far as the setup goes, if I have a right triangle, and let's say I already had the sides, the angles labeled, the angles will be labeled with capital letters. Then the lowercase letters are going to go on the sides, and you're going to label the side across from angle A as lowercase a. You're going to label the side across from angle B as lowercase b. And then your hypotenuse is going to be the lowercase c. When you're solving these right triangles, always try to use the given. Because if you use a calculated number and you've made a mistake, now the rest of your answers will also be wrong because you're using a wrong answer in the problem. So always try to use the given. Don't try to use a calculated number. When you're solving these right triangles, your calculator must be in degrees. And the way that you can confirm that is do tangent of 45, and then once you hit enter, you should be getting 1. If you get 1.6, you're in radians, and you need to go back to the mode and change the setup. So let's go ahead and take a look at our first example. Now, what we're doing today in the first part of the notes was something that should have been covered in your geometry class. You should have learned how to solve right triangles, and we're using our trig, our SOHCAHTOA. So when we're asked to solve the right triangle, what we're going to end up doing is finding all 3 sides and all 3 angles. So once I'm finished, I'm going to have the measure of angle A, the measure of angle B, the measure of angle C, lowercase a, lowercase b, lowercase c. Notice the lowercase letters are not on my picture. I'm going to add them in. So angle A is 31.67 degrees. Lowercase a is going to be located over here across from angle A, and this is equal to 35.9. And these are kilometers. Then lowercase b will be located across from angle B, and lowercase c is over here. Now, when I go to solve these other pieces, so let me go ahead and fill over here. So this is given to me, 31.67. Side length A is 35.9 kilometers. I also know angle C, it's the right angle. So really, when you're solving these triangles, you're always going to start out with 3 pieces of given. Now, when you do the trig, you never use the 90-degree angle. Now, I'm going to use, though, the 90-degree angle to find angle B. You should remember from geometry that the 3 angles of a triangle add up to be 180 degrees. You also should have learned a corollary that told you that the 2 acute angles of the right triangle are complementary. So to find angle B, all I have to do is take angle C, that measure 90, and subtract 31.67, and you're using your calculator. Once I do this subtraction, I get 58.33 for angle B. Now, the instructions say round to the 10th place, so we can put in here 58.3. So that's angle B. Now I only have to find 2 other pieces of information, side length little b and side length little c, the hypotenuse. Now, because angle B is a rounded answer, don't use that when you do the trig. Go back to the original given. So when I set up my ratios, I'm going to be using what was given to me, angle A and side length A. Don't use B, Because also, let's say your finger slipped on the calculator. And let's say when you tried to do 90 minus 31.67, your finger slipped and you got 56.33. And then if you try to use that to find the rest of the answers are going to be wrong as well. So what we're going to do is label the sides based off that given angle. So for my SOHCAHTOA, in relation to angle A, little a is the side that's opposite. Little c is always going to be the side across from the right angle, and it's the hypotenuse. And little b is my adjacent. So what I'm using to solve these right triangles is my SOHCAHTOA. So now I'm going to go ahead and look to see where my variable is that I want to solve for first. So let's say I want to solve for little b first. I'm going to look to see what I boxed in red. So adjacent and opposite, that's going to be the TOA. So I'm going to be doing tangent of 31.67 is equal to opposite over adjacent. And then I put the lowercase b here. Now, when the variable's in the denominator, we're really dividing to solve. Now, you can either choose to solve this as a proportion. You could put a 1 here and cross multiply. Or just know what you need to do is multiply both sides by b to get that out of there. So now I have b times the tangent of 31.67 equals 35.9. Because the sides that I'm looking for is the adjacent, and the given was opposite. So that's going to be the TOA, opposite and adjacent. You have to look at the sides. So now I'm going to divide both sides by tangent of 31.67. So on your calculator, you're going to do 35.9 divided by the tangent of 31.67. Once we do this, on your calculator, you're going to round to the tenths place. You're going to get 58.195. It's going to keep going, but I only need to take it out 2 places because I'm rounding to the tenths. So 58.2 kilometers is lowercase b, the adjacent side. Now, to find the hypotenuse, over here, my hypotenuse is here. And again, I'm using my given. Don't use this newly calculated number because number 1, it's rounded. And number 2, if you've made a mistake, then C is going to be wrong as well. So I'm going to be using hypotenuse and opposite and the original acute angle they gave me. So opposite and hypotenuse, that's the SO. So I'm going to be doing sine of 31.67 is equal to opposite 35.9 over lowercase c. So again, I need to solve this. If you want to add a 1 and instead treat this as a proportion and solve it with cross products, you can do that. It's the same thing as multiplying both sides by c. So you would end up getting sine of 31.67 times c equals 35.9. Divide both sides by the sine of 31.67. And then you should be getting 68.377, so 68.4. And these are kilometers. Now that we have found all 3 sides and all 3 angles, then we are finished. We have solved the right triangle. When you're done with this, make sure your answers make sense. Okay, when you're looking for the 2 acute angles, they should be angles that are less than 90. When you're looking for the hypotenuse, it should always be the biggest number. If it's not, you've done something wrong. Technically, we could also do the Pythagorean theorem to check your answers, because if a squared plus b squared doesn't give you close to c squared, then you've done something wrong as well. Now remember, these are rounded answers, so you may not get exactly a squared plus b squared to equal c squared, but it should be pretty close, within a few decimal points. Here's the next one. So again, let's label. Again, the lowercase letter goes across from the angle. So this is lowercase a, lowercase b, lowercase c. They're giving me the hypotenuse this time. So this is going to be 89.6 centimeters. And then they gave me the acute angle of 47.8. So now, when we're done, we're going to have angle A's measure, angle B, which they gave me. I also know angle C, it's the right angle. And then I'm going to know lowercase a, b, and I have c that was given to me. So now, again, I'm going to label my sides in relation to the acute angle that is given to me. So this is going to be lowercase b over here, which is going to be opposite to the given angle. This one's going to be adjacent, and this is hypotenuse. Now, you should always label the hypotenuse first, because technically it is adjacent to angle B, but the better name for it when it's across from the 90 degrees is the hypotenuse. So now I'm going to go ahead and find the acute angle first. I'm going to find angle A. That's the easiest one to do. All I have to do is take 90, subtract the angle they gave me. So 90 minus 47.8, and I get 42.2. Yes. Remember, the three angles of a triangle, if you wanted to check your calculations as well, these three angles need to add up to be 180. If they don't, again, you've done something wrong. Now, I'm going to go ahead and circle what was given to me. I was given the hypotenuse, and this is my acute angle. So if I want to find little a first, little a is adjacent. So I have to figure out which one is going to use adjacent and hypotenuse, and that's the ka. So I'll be doing cosine of 47.8 is equal to adjacent over hypotenuse. Now, when the variable's in the numerator, what we're doing is multiplying to solve. So we're going to multiply both sides by 89.6. That'll cancel. So on your calculator, you are doing 89.6 times the cosine of 47.8. Once you do that, you should be getting 60.186. It's going to keep going, but we're going to round it to the tens place. We really only need to put two numbers here after the point. The 8 tells the 1 to round up, so A is equal to 60.2 centimeters. So B, again, I'm still using my original. I don't want to use this newly calculated number, because if I did something wrong, then for sure my B is going to be wrong as well. So yes, opposite and hypotenuse. So I'm going to be doing sine of the same angle, 47.8, is equal to opposite over hypotenuse. And again, I'm going to multiply both sides by 89.6.
It's the same thing. It's different letters.
Multiply 89.6 times the sine of 47.8. You should be getting 66.376. Round to the tenths place. The 7 tells the 3 to round up. So B is equal to 66.4 centimeters. So I have solved the triangle. I now have all three side lengths and all three angle measures. And again, make sure your C value is the biggest number, because it's the hypotenuse. and the hypotenuse is always the biggest side of the right triangle. Next one, same thing. So I'm going to go ahead and draw a picture, and I'm going to label it. So I'll go ahead and draw my right triangle. Now on the test, more than likely, this is how you're going to be given the question. You're going to have to label it yourself. So notice the restriction here is C is the right angle. So if I go ahead and label it the same way it was set up before, actually it was different on both. So it doesn't matter where you put A and B, it just matters where you put C. So if I put B up here and A here, then again, the side across from angle B is the lowercase b, the side across from angle A is lowercase a, and C is the hypotenuse.
So does it matter where you put?
Let's fill in what they gave us. They gave us angle A, it's 61 degrees. They gave us lowercase b, and this one's going to be 39.2 centimeters. So let's set up what we're filling in. Angle A, I have 61 degrees. Angle B, I don't know. Angle C is 90. Lowercase a, lowercase b, and C, and B was 39.2. Now, again, I'm going to go ahead and just find my other acute angle. So to find angle B, all I have to do is 90 minus 61, and angle B is 29 degrees. Again, the three angles should add up to be 180. If they don't, you've done some kind of calculation wrong. Now, again, I'm going to circle what was given to me. So they gave me angle A and side length B. I'm going to label my sides in relation to angle A. So the little lowercase a is opposite, hypotenuse, and then lowercase b is adjacent. Okay, so we're going to be doing TOA to find lowercase a. So tangent of 61 is equal to opposite over adjacent. Okay, so now, because my variable is in the numerator, I'm going to go ahead and I have to multiply to solve. So I'm going to multiply both sides by 39.2. So I'm going to do 39.2 times the tangent of 61, rounded to the tenths place, 70.7. And these are centimeters. Now for the hypotenuse. So again, we're going to circle what we have. So we were given adjacent and hypotenuse. So that's going to be ka. So we're going to be doing cosine of 61 is equal to adjacent over hypotenuse. So this time my variable is going to be in the denominator. So 39.2 over C. So again, you could either solve it as a proportion or multiply both sides by C to get that out of the bottom of the fraction. So cosine of 61 times C equals 39.2. Divide both sides by cosine of 61. And lowercase c, that hypotenuse, 80.9 centimeters. So now I have completed the triangle, 70.7, 80.9. And again, make sure it's making sense. One other thing that you should have covered in your geometry class, let me just go ahead and draw it larger here. So this angle was 29, angle B. Lowercase b had a length of 39.2. Notice this is the smallest side length, and it's across from the smallest angle. The biggest angle is the 90, and it's across from the largest side. And then the medium or the middle angle, the 61, it's across from the medium size angle. So it needs to make sense. The smallest angle always has the smallest side across from it. Largest side always has the largest angle across. So just make sure it's making sense. Move down here a little. So redraw the triangle. So B, and again, C has to be the right angle. Doesn't matter where you put A and B. Once you put in the angles, the capital letters, make sure that the lowercase letter is across from that capital letter. And then lower B here and lower C here. So in number 4, they gave me angle B, which is 46, and they gave me side length C, which is 29.7 meters. So angle A, angle B, angle C, C is 90, B is 46. To find A, 90 minus 46, and it's 44. Now we got to find lowercase a, b, and c. C was given. So let's label them in relation to the 46. So in relation to the 46, opposite, hypotenuse, and adjacent. So if I want to find lowercase b, I'm going to be doing sine. So the sine of 46, opposite over hypotenuse. This is so. So I'm going to multiply both sides by 29.7. So when the variable's in the numerator, you're multiplying to solve. And then you get lowercase b is 21.4 meters.
Sine 46, 29.7.
And now to find lowercase a, now it's cosine because it's adjacent and hypotenuse. So sine of 46 is equal to a over 29.7. Again, it doesn't matter which one you solve for first, because always try to use the given. Don't try to use a newly calculated number. So I'm going to multiply here, and I end up with a is equal to 20.6. Oh, cosine, you are correct. Thank you. Cosine of 46. And you should get 20.6. So now I've found all of my missing sides. 20.6 meters, 21.4 meters. Now, notice all of the examples I've done up to this point have given me one angle and one side. Now I'm going to give you two sides and no angle measures. This is where we're going to do the inverse operation on our calculator, which is going to be the second key or the shift key. And then you hit the trig function, whichever one you're setting up. So let's try it. Again, no picture provided. Let me go ahead and draw one. And again, it doesn't matter where you put A and B, but again, C is the right angle. So C is the right. I could put B here, A here, lowercase b, lowercase a, and C. So this time, they're giving me two sides, however, no acute angle. So for this one, again, let's go ahead and find the missing side first. So we're not going to use a trig function to find C. We're going to use Pythagorean theorem. So when you're given two sides, you're going to be doing a squared plus b squared equals c squared. So a is 958. You're going to square it. Then 489, square it. You don't have to put parentheses. It's not negative or anything. So then once you square that, you get 917764. And then here, 489 squared, 239121. You have to add that, and then you're going to square root it. And we're going to round to the tens place. So once we square root it, you should be getting 1075.59. And then you're going to round to the tenths, so 1075.6 meters. So that's my missing side C. So this is where we're going to use the inverse. So all we know so far are the three sides. So we know lowercase a, it was given. Lowercase b, it was given. We just calculated C to be 1,075.6, and we also know angle C, it's 90. Now, again, it makes sense. The biggest side that we have out of the three is the 1,075, and it's the biggest side because it's across from the biggest angle. Now, again, I'm going to use my original. So I'm going to use A and B. So when I want to find angle A, I'm going to label those two sides that I circled in red in relation to A. So this is adjacent to A, and this one's opposite to A. So opposite and adjacent is going to be tangent. So in order to find tangent of angle A, I'm going to be filling in opposite over adjacent. But on your calculator, you're going to be doing the shift key or the second key. It should open up tangent -1, and then you're either going to enter this as a fraction or as division. And then hit enter, rounded to the tenths place. This should end up giving me, actually nearest degree. We're going to round this to the nearest degree. Second tan. And then it should open up in your screen, tangent raised to the -1 power. And then in the parentheses, you're going to do either as a fraction or 958 divided by 489. Close the parenthesis, hit enter. Rounded to the nearest degree, 63 degrees. Now, to get the other acute angle, if you were confident with what you did, 90 minus 63, and it's 27 degrees for angle B. Now, you could also do another trig function for it. You could also do tangent of 489 divided by 958, and then still get 27 rounded. Because then what you would do for this one is you change the labels here. This now becomes adjacent to B, and this one becomes opposite. That's why you flip the fraction. So this would be a way you could check that just doing 90 minus the angle you calculated makes sense. So A was 63, B was 27. So for number 6, let me draw the triangle. So I've given two sides again. So again, I could label. So I'm giving side A, 26.5. I'm giving C, the hypotenuse, 39.7. I don't know lowercase b, so I could do Pythagorean theorem to find lowercase c. And then A, B, C here, 26.5 centimeters, 39.7. And then I also know this is the 90 degrees. So let's do Pythagorean theorem to find lowercase b. So a squared plus b squared equals c squared. 26.5 squared plus b squared equals 39.7 squared. Once I square these numbers, 702.25 plus b squared equals 1576.09. I need to isolate b squared, so subtract 702.25. B squared equals 873.84. Square root it, round to the tenths place, 29.6. And these were centimeters. So that's our lowercase b. Now again, I'm going to label my sides first to find angle A. So in relation to A, this is opposite, and this is going to be hypotenuse. Now in relation to B, this is opposite, and this would be adjacent now. This is still hypotenuse. So again, you can choose to do one and then just subtract from 90, or do two trigs for each of the angles. So if I do A, opposite and hypotenuse, that's going to be sine. So I'm doing inverse. So I'm going to be doing sine of A is equal to opposite over hypotenuse. And again, we're doing the inverse. So sine -1, and then put in the 26.5 divided by 39.7, or enter it as a fraction. And then angle A, rounded to the nearest degree, 42 degrees. And now to find angle B, you can either do 90 minus 42, and angle B equals 48 degrees, or do the reciprocal, or cosine -1, and flip this to 39.7 over 26.5, and again, you still get angle B equals 48 degrees. So my triangle is complete. Angle A was 42, angle B is 48. So it says to find the indicated trig functions, round your answers to 3 decimal places. Now, on your calculator, there are no buttons that say secant, cosecant, cotangent, so this is where we need to use the reciprocal identities. So you should know that the reciprocal to secant is cosine. So what we're going to do is 1 over cosine, 31.67, hit enter, rounded to 3 decimal places, 1.175.